Good afternoon, everyone. I hope you're having a great day and that your ending of the day, it's amazing. Today we'll we have two amazing hosts and two amazing guests, I'm sorry. And we are going to introduce them hoy. Vamos a tener a dos invitados y vamos a introducirlos. Las pláticas van a ser en inglés y en español también para el día de hoy. Entonces, estamos muy felices que estén aquí, bienvenidos. También va a haber una rifa del libro de Bruce y Ana Luisa, que por cierto lo acabo de terminar de leer la semana pasada y estuvo increíble. Creo que es un libro que todo el mundo debería leer. Así quieran trabajar en la NASA o quieran ser ingenieros o quieran ser científicos o artistas o lo que sea, creo que es muy inspirador. Y todos deberían leerlo, y sus hijos deberían leerlos, y todos los deberían leer, es muy, muy bueno. Entonces lo vamos a rifar al final de la conferencia de hoy. Entonces, vamos a pasar a inglés en este momento, para que todas las personas que están en nuestra plática puedan incluirse. Entonces, good afternoon, everyone. We were talking about that we'll have a raffle after everyone's speaking tonight. So we'll raffle Bruce and Ana Luisa's book. It's amazing. Everybody should read it. So let's start. Today we're gonna learn some educational possibilities in Canada. And for that we have Alexander Leon, and he works in the Canadian Embassy. So Alexander, please.
I just received an email which popped up in my phone, which says your data is gone. So let's hope that it doesn't end. I have a plan B anyway. No sé si está bien si hago la presentación en español, porque vengo preparado para español. Entonces va a ser un poco más fácil.
Claro, no hay problema.
Así
claro,
que,
no hay problema.
Gracias. Vamos a compartir acá. Y vamos a hablar un poco. Me dicen que tengo como unos 15 minutos, así que vamos a tratar de aprovechar el tiempo al máximo. Quisiera, Andrea, si me hicieras el favor de poner por un momento el video que habíamos preparado. Es un video de máximo 3 minutos.
So, you're looking to study abroad? And you want to go to a country that will offer a wide variety of experiences and exciting work opportunities? Well, Canada might just be the perfect fit for you. With breathtaking landscapes, vibrant cities, and lively cultures, Canadians enjoy a quality of life that is one of the best in the world. We are renowned for our competitive and entrepreneurial economy. Our society is safe and multicultural, which makes Canada the perfect study destination, no matter who you are or where you're from. Plus, we have one of the best education systems in the world. Did you know that 10% of Canadian universities rank in the top 200 best universities worldwide? And since our institutions are publicly funded, high-quality education is consistent across the country. Canada offers more than 15,000 undergraduate and graduate degree programs across the country, and over 8,000 college diplomas, postgraduate certificates, or applied degrees. If you want to hit the labor market quickly, you'll also find a wide range of hands-on programs that will help you do just that. Not sure about your career path? Our Canadian education institutions make it easy for students to switch between study programs. To top that, Canada offers unmatched working opportunities. While many study destinations don't allow international students to work during their studies, in Canada, you can work off campus for up to 20 hours per week and full-time during school breaks. Looking to stay in Canada after your studies? You should know that Canada provides a variety of work permits and immigration programs only available to international graduates, making it easier for you to work and stay in Canada after graduation. Now you're telling me, that's awesome, but how can I find the right education institution for me? It's simple. Just visit educanada.ca and browse the list of college and university programs to find the program that's right for you. A bright future is at your fingertips. Come study in Canada. A world of possibilities awaits.
Gracias. Bueno, ese video de 3 minutitos resume todo lo que voy a presentar y más. Así que vamos a ir pasando algunas filminas y vamos a ir hablando. Soy el agregado comercial de la Embajada de Canadá. Mi función es ayudar a las empresas a conocer oportunidades comerciales y lo hacemos tanto para Honduras, Nicaragua y Costa Rica. Entonces ayudamos a las empresas canadienses, pero también ayudamos a los estudiantes a conocer un poco sobre Canadá. Bien, mi presentación se llama Vive, Aprende y Ten Éxito. Entonces, la primera Vive trata un poco de ver qué es Canadá, cómo es vivir en Canadá, un país de 10 provincias y 3 territorios. Un país donde está, al igual que Costa Rica, tiene muchos estereotipos, ¿verdad? Aquí piensan en Costa Rica, pura vida. Bueno, Canadá, frío. Canadá, nieve. Canadá, bueno, un montón de estereotipos como ven ahí, inglés y francés, etc. Sin embargo, Canadá es un país muy diverso, es muy bonito. Los ticos cuando van a Canadá se enamoran de Canadá, como los canadienses se enamoran de Costa Rica cuando vienen, porque los dos países son tan diversos como diferentes en tamaño son. Entonces, a los canadienses les encanta venir a Costa Rica porque ven mucho en un espacio pequeño y allá se ven bellezas enormes en lugares enormes también. Bien. Algunas características de vivir en Canadá es que es muy seguro, es muy estable. Hay un sistema educativo y de salud que son fundamentalmente públicos. Hay infraestructura muy avanzada. Hay una serie de ventajas. Pero yo tengo 12 años de estar con la Embajada de Canadá y les quiero decir que lo que más me impresiona de Canadá es la multiculturalidad de ese país. Es el hecho de que vas a una ciudad y te encuentras gente de todo el mundo. Si quieres, no sé si hay más países que tengan esas características, pero de los que conozco es el que más me impresiona, porque la gente se ve y nadie se preocupa de que si soy de esta etnia o soy de esta cultura o si trabajo con gente de otras. Eso no importa, lo importante es que se convive y se convive pacíficamente. Entonces es bien agradable eso. Hay mucha tolerancia y eso está dentro de la misma constitución del gobierno de Canadá. Bien, además de eso, vivir en Canadá es una de las naciones más competitivas. Tiene muy buenos rankings a nivel internacional, tanto en el área financiera como en el área de hacer negocios, como el tema de emprendimiento, como lo vamos a ver ahora. Tiene también una de las economías con menos problemas de corrupción. En Canadá la corrupción es severamente castigada y perseguida y entonces pues eso asegura que haya menos casos. Siempre va a aparecer alguno por ahí que haga una de estas fechorías, pero no es lo usual, ¿verdad? Bueno, algunos de los descubrimientos de Canadá, algunos de los emprendimientos que ha hecho Canadá, ¿verdad? Hay una serie de ecosistemas y en esta parte me quiero detener porque de acuerdo con lo que a ustedes les interese, les interese estudiar o desarrollarse, deberían de ver esto. Por ejemplo, si nos vamos a queremos estudiar inteligencia artificial, bueno, hay ciudades que tienen clusters de empresas y centros de emprendimiento enfocados, por ejemplo, en inteligencia artificial, o en ciencias de la salud, o en robótica, en todos esos temas modernos. Acá hay algunos de los principales productos donde Canadá ha tenido contribuciones específicas. No me voy a detener a comentarles qué parte de la pelota de básquetbol, en qué aportó Canadá allí. Con gusto con más detalle lo hacemos, pero sé que estoy limitado de tiempo. Pero estos son algunos de los emprendimientos, algunas de las innovaciones de Canadá también. Ha ganado también, ay, ¿qué pasó aquí? Perdón, se me pasaron unas filminas. Ha ganado premios Nobel, ha tenido importantes descubrimientos. Entonces, para vivir en Canadá, esa es mi parte de la presentación. El segundo tema tiene que ver con lo que a ustedes más les interesa, que es con el hecho de aprender. Es uno de los países con no solo mejor calidad de vida, sino también uno de los que más invierten en investigación en todo el mundo. Canadá tiene, si en ese momento me dicen, tienes que parar la presentación, dime 5 cosas de Canadá. Yo le voy a decir, bueno, la primera es la multiculturalidad. La segunda es que el costo de estudio es muy competitivo comparado con otros países. El tercero es que definitivamente es un lugar donde se puede estudiar con bastante tranquilidad, bastante seguridad, ¿verdad? Entonces, son elementos importantes. El cuarto es que puedes trabajar mientras estudias. Y el quinto es que tienes un ambiente colaborativo de empresa privada, academia. Entonces, en estos 3 hace una investigación colaborativa que asegura que todo lo que se produce va a tener un beneficio para todos. Esa parte, lamentablemente, en Costa Rica apenas estamos aprendiendo eso. Pero bueno, esperamos llegar a ese punto, ¿verdad? Bien. Algunas de las universidades están rankeadas entre las mejores. Depende, cada universidad tiene diferentes especializaciones, entonces hay universidades muy fuertes en diferentes carreras. Además de eso, podemos obtener diferentes titulaciones en cada una de las universidades y colleges. Y aquí me quiero detener porque muchas veces no comprendemos cuál es el concepto de college. Y un college es un instituto para universitario, donde puedes, si quieres seguir a la universidad, o tienes una salida vocacional o una salida técnica. La ventaja de los programas de colleges en Canadá es que son muy amplios, entonces una persona, y de hecho ocurre mucho que hay estudiantes que haciendo su universidad quieren obtener una formación práctica, entonces van a un college. Y también tenemos estudiantes de college que después deciden irse por la parte más académica. Entonces la diferencia entre una universidad y un college muchas veces es que el college va a tener muchas más salidas, es decir, opciones de títulos, mientras que una universidad va a ser mucho más enfocada en investigación. ¿Qué otro elemento más importante? Bueno, la maestría, doctorado, todos conocemos sobre eso, no me voy a detener allí. Lo importante es que sí, Canadá tiene un poco más de 15,000 programas donde se puede aplicar. Y lo que les decía antes, ¿verdad? En materia de investigación y desarrollo, que es uno de los puntos para mí más importantes, es el hecho de que Canadá ocupa una posición de líder o de los principales, ¿verdad? Países que invierten en ese tema. Y en las áreas donde ustedes se especializan, son muy enfocadas casualmente en investigación y desarrollo. Hay más de 2,000 cátedras de investigación, ¿verdad? Hay millones de dólares, 265 millones. Esto es una presentación del año 2019 que se utilizan para atraer académicos científicos. Hay una serie de áreas en las que se está haciendo investigación, ¿verdad? De robótica, nanotecnología y también en ciencias aplicadas a necesidades específicas como agricultura, pesca, silvicultura, etc. Bueno, creo que ya hablamos un poco de esto, los EGEPs y que son los mismos colleges, ¿verdad? Los EGEPs es el nombre que se le da ¿cómo se llama? En Quebec. Bien, vamos a ver acá, voy a pasar, que sé que tengo poco tiempo. Ok. La posibilidad de moverse de una institución a otra es importante de valorar. Pero puedo iniciar, las universidades y los colegios me permiten ir pasando de una institución a otra. Tengo esa ventaja de movilidad. El sector TIC, que es el sector de que a ustedes les interesa, Canadá cuenta con 32,000 empresas, entonces, en esa área. Y esta parte me quería detener porque es importante que muchos de los estudiantes que están llegando a Canadá. En este momento hay más de 500,000 estudiantes internacionales estudiando en las universidades y colegios canadienses y colleges canadienses. Entonces, cuando se estudia ya se conoce gente de todo el mundo, pero además de eso también puedo yo trabajar o hacer pasantías en mi especialidad o en lo que estoy tratando de estudiar. Entonces acá hay algunos datos importantes de conocer en el área de tecnología, en ciencias, también hay universidades muy bien rankeadas, en medicina, en farmacia, en esas áreas que a ustedes les llama la atención. Nuevamente, mi objetivo no es hablarles de un programa específico, ¿verdad? Sino más bien motivarlos a que investiguen un poco más y ahorita les voy a explicar dónde. Bien, ten éxito en Canadá tiene que ver con el hecho de que puedes trabajar tanto durante tus estudios como cuando terminas tus estudios. Entonces, si haces tu colegio en college, digamos, o tu universidad en Canadá, 4 años, tu pregrado, vas a tener la posibilidad de trabajar tantos años como años estuviste llevando universidad. Es una ventaja. Eventualmente, si te gusta y quieres aplicar por la residencia, lo puedes hacer también, aunque no ese es el fin, digamos, de la presentación, ¿verdad? Se puede trabajar entonces con pasantías, en prácticas, incluso puedes trabajar en áreas que no son de tu especialización mientras vas creciendo en tu carrera. Lo único que sí no te permite trabajar es si estás aprendiendo el idioma inglés o el francés. Entonces, hasta que no estés formalmente en un college o en una universidad, no vas a poder trabajar. Bueno, en temas de inmigración, también Canadá tiene mejores posibilidades, ofrece mejores posibilidades que muchas de las otras naciones desarrolladas. En costos de estudio también. Ok. Aquí quiero hacer un alto, digamos, un poco ya como para comentarles qué es vivir en Canadá, cuáles son las ventajas que les comentaba. Y voy a pasarme al tema de cómo averiguo dónde o qué opciones o cómo empiezo cuando quiero conocer a dónde acudir para obtener más información. Entonces, el primer sitio, el sitio oficial del gobierno de Canadá es educanada.ca, que es el que se hablaba en el video. Entonces, aquí hay, por ejemplo, una búsqueda que hice sobre Space Engineering. Entonces, voy a cambiar de New Share y nos vamos acá. Ok. Entonces, ese es el sitio web de EduCanada. Entonces, entramos a EduCanada. Creo que me puedo devolver acá un momento. Sí. Ok. Acá está el sitio de EduCanada. Luego vengo. Ahí está toda la información que ustedes quieran en materia desde becas, vivir en Canadá, trabajar en Canadá, todo el proceso migratorio, etc. Por ejemplo, si yo quiero conocer las universidades, entonces me meto donde dice Find Programs and Costs. Acá es el único que sí tiene el sitio es que solamente está disponible en inglés y en francés. No lo vamos a encontrar en español, pero creo que para ustedes no es un problema esto. Ok. Yo quiero buscar, entonces, por ejemplo, programas. Entonces, vengo acá y busco Feature Study Programs. Perdón, creo que no es acá, sino es en el otro. Es encontrar programas, buscar colegios y universidades. Ok. Acá está el buscador donde se encuentran todas las carreras, perdón, o las ofrecidas en las universidades y colegios o colleges de Canadá. Entonces, ¿qué es lo que tenemos que hacer? Es tan sencillo como escribir una carrera. Entonces, yo pongo Space Engineering. Si quiero, puedo hacer algunos filtros. Si quiero, puedo buscar categorías de acuerdo con la carrera que quiera. Y si quiero, incluso puedo buscar qué tipo de nivel. Si quiero Training College, University, qué tipo de nivel quiero buscar. Incluso puedo seleccionar la provincia de interés. Y aquí quiero hacer un paréntesis, porque los costos de estudio, al igual que en cualquier otra nación grande, varían mucho de una provincia, digamos, donde hay más gente, de las más habitadas a las menos pobladas. Entonces, no es una regla escrita en piedra, pero, por ejemplo, las ciudades más grandes tienen costos de vida más altos. Entonces, no es lo mismo estudiar que en Ontario, que, digamos, en Toronto. ¿verdad? Que estudiar tal vez en, no sé, New Brunswick, por ejemplo. Entonces, eso es importante. Y el otro tema también tiene que ver con, sí, muchas veces los impuestos en una provincia son diferentes de los impuestos en otras. Entonces, ahí puede haber un impacto. Bien, pero el sistema te permite calcular los costos incluso de vivir en algunas de estas provincias. Entonces, vamos a seleccionar acá, como les decía, Space Engineering. Le doy, voy abajo y le doy buscar. Display una lista de programas. Acá nos encontramos todas las universidades y colleges que ofrecen lo que andamos buscando. Bachillerato en ingeniería aeroespacial. Y lo interesante es que yo puedo seleccionar y comparar. Entonces, yo puedo selecciono, acá hay un espacio y voy y selecciono, no sé, otra Carlton, por ejemplo, no sé. Debería comparar los que fueron bachiller y todo, pero bueno. En fin, selecciono esos dos y le doy acá, confirmar selección. ¿Qué pasó acá? Ah, bueno, acá selecciono si voy a ir solo, si voy a ir con mi esposa, con mis hijos, ¿verdad? Porque eso va a tener un impacto en los costos, porque acá estamos en la parte de calcular costos de estudiar en Canadá. Confirmo la selección, asumo que voy a ir, perdónenme, voy solo. Vuelvo a confirmar las dos instituciones, que, perdón, elegí dos de Ontario. Vamos a ver, voy a devolverme un momentito, solamente para, es que me gustaría elegir dos que sean de diferentes provincias. Poco para poder comparar costos. Ok, vamos a ver, elegimos este de Ontario. Y veamos si algo. Aquí hay Winnipeg, ok, perfecto. Entonces, asumimos que vamos a ir solos nuevamente. Ok. Ok, acá están los costos de ir a un lugar o ir al otro. Entonces, yo no, aquí tengo una imagen, ya lo puedo aquí, ok, perfecto. Entonces hay costos muy diferentes de ir a un lugar al otro, lo que les decía. Entonces también depende, esto es importante porque también tengo que ver mi presupuesto, ¿verdad? Son costos promedio e incluyen absolutamente todo, ¿ok? Son dólares canadienses también, esa parte es importante. Luego queríamos enseñar, bueno, acá, y si ustedes seleccionan, por ejemplo, Ryerson, entonces me va a llevar a la universidad, me va a poner, esta no funcionó, siempre sucede la ley de Murphy. Yo creo que, ok. Entonces ahí me sale la información, me sale con quién tengo que hablar, me salen los diferentes personas que puedo específicamente pedir más información en la universidad, etc. Creo que con esto yo termino mi presentación. No sé si tienen alguna pregunta para no alargarme más. Sé que tengo que respetar el tiempo, así que creo que es suficiente, ¿no?
Alexander,
Sí.
no, hombres, muchísimas gracias por su presentación, de verdad. Más bien yo le iba a preguntar si usted podría compartirnos las slides que usted tiene o tal vez su contacto para que todos los miembros de SWICE tengan acceso a esto, ya que es súper importante. Entonces, si nos los puede compartir y si ellos tienen preguntas para que le puedan escribir directamente.
Ok, con mucho gusto. Solo voy a hacer, bueno, no sé, primero quiero ver si hay alguna pregunta y si no hago un comentario.
No sé si alguien tiene una pregunta, porque ya nos estamos quedando sin tiempo, chicos. Entonces,
ok, un comentario muy breve, entonces, dado que no hay preguntas. Para las personas que estudian en universidades en Costa Rica, el gobierno de Canadá ofrece unas becas de corta duración de 4 a 6 meses para ir a estudiar a una universidad en Canadá que tenga un convenio con esa universidad. Entonces, si ustedes son universitarios, digamos, del TEC, de la UNA, de la UCR o cualquier otra universidad, el tema es que hay un convenio, lo hacen, se comunican con su universidad y si no existe un acuerdo, nosotros ayudamos a establecer ese acuerdo entre las dos universidades de forma que el estudiante pueda ir a participar en eso. Esa parte es importante. Para que no pierdan la oportunidad porque esas son becas totalmente pagadas por 4 meses y las paga el gobierno de Canadá. Y además de eso, que es importante, tenemos una situación, que es que no están aplicando suficientes estudiantes. Quisiéramos ver más costarricenses allá. ¿Ok? Son más de 600 becas que se dan en Latinoamérica, así que aprovechenlas. Gracias.
Muchísimas gracias, muchísimas gracias. So now we're gonna present an amazing human being. She's really inspiring. Lindsay McLaurin is the Solar System Public Engagement Lead at the Jet Propulsion Laboratory, JPL. McLaurin is the Public Outreach Lead for the Juno, Europa Clipper, and the Psyche missions, responsible for bringing awareness to the educating the public on the importance of the exploration and science associated with these missions. McLaurin also served as the Senior Principal Public Relations Lead for the NASA James Webb Space Telescope program, where she oversaw media relations, digital media, public outreach, and internal communications. Ms. McLaurin received a bachelor's degree in marketing management from the Virginia Polytechnic Institute and the State University in 2008, and a master's degree in corporate communications from Johns Hopkins University in 2018. So right now we're gonna start with Lindsay McLaurin, and hi, Lindsay.
Hello, everybody. I am going to share my screen. Thank you so much for having
Oh,
Something happened. We lost her.
yes, I think we lost you. Lindsay, are you there? Oh, I think she had a little issue, so we'll just wait for her just one little second.
Something important about Lindsay's work. Today we're having our final JPL Speaks to Costa Rica personality. So after today, we're finishing this series. We've had 6 distinguished guests from the Jet Propulsion Laboratory. And we're looking forward to hearing and learning about Europa, one of the moons of Jupiter, and NASA's upcoming mission. It's called the Europa Clipper mission, which was approved for funding about 1.5 years ago. So these things can be really difficult in NASA. Who gets the money, who doesn't? And so we're looking forward to hearing all about Europa and other missions that we're working on with Lindsay. So I'm not sure exactly where we lost the signal, but we'll wait here for a few more minutes.
Bruce, do you have any way to contact her? Perhaps she hasn't realized that she's gone out of.
Yeah, I've tried to actually reach her.
Mm-hmm.
Let's see what we can find here.
I'm receiving, in the meantime, I'm receiving a couple of messages asking for the presentation. What I'm gonna do, Andrea, is I'm gonna send it to you because I know that it's over 12 megs, so I need to kind of reduce it or do something to be able to send it. I'll send it to Bruce, and then Bruce can redistribute it to the rest of it. And my contact information is gonna be there as well.
That would be amazing. I think we're very interested. There are great universities in Canada. So yeah, we really need to see the presentation and have more details. It was really fast. So
Yeah, I know.
so yeah, as long as we have the presentation, we can see
Yeah.
it. Hi, Lindsay.
I am so sorry about that. My computer just shuts off sometimes, and of course,
Oh.
when I don't want it to shut off, it does that. Okay, thank you for the kind introduction and bearing with me. All right, during that technical difficulty. Can everyone see my screen okay? Yes, awesome. So for those of you who may not be aware, what Jet Propulsion Laboratory is, it is a federally funded research and development facility of NASA, the National Aeronautics and Space Agency of the United States. Jet Propulsion Laboratory is located in Pasadena, California, which is right outside of Los Angeles, California, where I live. This first slide shows a really great and beautiful picture of the campus that before the coronavirus, I was able to go to every day. We're situated right into the mountains, so it's a really great view. As I was so graciously introduced, and you can see my photo right here, and what I might do if I have a bandwidth issue, I might turn my laptop off, my camera off, but so you can see my face. As mentioned, I am the public outreach lead for the Europa Clipper, Juno, and Psyche missions. These are 3 missions, NASA missions, that are being managed out of Jet Propulsion Laboratory. And so you're probably wondering what public outreach is. So my role is responsible for bringing awareness and education to the importance of space exploration, science, and technology associated with not just these missions above, but as the solar system as a whole. So these include public events, trade shows, digital products, website design and content development, and social media posts. If you follow any of NASA's great social media missions or flagship page, my work can be contributed there as well. If you're ever so lucky to come to a NASA event, then we have really great printed products. If I was back at work, I would send you guys a care package filled with NASA stuff, but I will keep in touch with Bruce. And so when I'm able to get back on lab at JPL, I'll try to get a care package for you guys, but bear with me. I don't know when I'll be allowed back on lab, but I'll definitely make sure I get you guys some really great NASA stickers and some mission swag, and also educational engagement. We have an office of education that's filled with teachers in the STEM field, outside the STEM field, K through 12, and at the academia collegiate level, to just create products and help students of all ages learn more about the work that we do at NASA. And so this slide is just kind of gives an overview of how NASA views it. It's an umbrella term, public outreach, to define the strategic communications initiatives to help inform, educate, and engage the public. This photo here is a really great pictures of these kids looking and exploring in a box. So I love doing any type of outreach events of any ages, honestly. The cool thing to see is being at a trade show that is of academic or filled with folks and STEM professionals, and seeing them look just as excited as kids and wonder to get stickers and learn about the missions as well. So that's a really great part of my job, that I actually get to see the engagement and impact that myself and my colleagues are making. So now I wanted to give you a little bit of information about one of NASA's flagship missions called the Europa Clipper. It is set for a launch readiness date of about the summer of 2024. So we are about 4 years away from this mission, but it's never too early to get folks engaged and to learn more about the great work that we do. So as most of you are probably aware, that Galileo Galilei discovered Europa and Jupiter's 3 other largest moons, Io, Ganymede, and Callisto, more than 400 years ago. And as you can see at the top, I was about to point my screen, but you can't see it. Those little star squiggles are actually taken from his book, and are what he used to depict what he saw in the night sky. So you can see where the circle is Jupiter, and then the stars on either side are supposed to be representative of the moons that he discovered. He revolutionized the way that we look at humanity and our place in the universe, which is so amazing. The best evidence that we have of these different moons is the NASA's Galileo mission, which orbited around Jupiter from 1995 to 2003. This spacecraft made more than 12 close flybys, which one of the instruments detected ocean on Europa's mission. And so this is how we came to be, and scientists have really great hopes of what Europa will be able to show us. So Europa is what we call an ocean world, right? It has the most promise for life, and the idea that there could be habitability outside of Earth. Europa will hopefully, once we go there, be able to answer those questions. Europa is about 484 million miles away, and it has conditions favorable for life. And scientists are going to send the Europa Clipper, spacecraft to go and conduct its first detailed studies of this ocean world. The main science goals of the Europa Clipper mission is to investigate habitability, and it will do that by observing these three main parts, which is the ice shell and ocean, composition, and geology. And I'll go over those a little bit more in the coming slides. This slide is a depiction of Europa's surface. So like I mentioned before, the outer shell or crust of Europa Clipper is dense, thick ice. And it has a lot of really great patterns. As you can see, some of these are highlighted to the right. It has ridge plains. It has a chaos terrain that's been looked at a few different times to possibly have water vapor and volcanic type of craters that scientists want to learn more about. Craters in the bottom and lenticulae. So it's really cool that you can see all of these really great images of Europa's surface. And I particularly like this because it reminds me of snowflakes right here on Earth. No snowflake, one snowflake is like another, and no ice structure or pieces of the surface of Europa are like one another. So this is a water ice surface, and it's crisscrossed by the different types of surfaces I've mentioned: long, linear fractures, cracks, ridges, and bands. And the moon's ice shell is probably 10 to 15 miles or 15 to 25 kilometers thick. And what lies beneath is an ocean that is estimated to be 40 to 100 miles or 60 to 150 kilometers deep. And so what makes up Europa, excuse me? The icy shell that we talked about, and underneath that, a saltwater ocean. So the coolest thing about a saltwater ocean is that that is where we all know where half of the life on Earth lives, is underneath the oceans. While you have humans like you have animals, you have all sorts of different insects and bugs that live above the surface, over half of life that we have on Earth is underneath the ocean. So from that idea, it's a really great probability, scientists believe, that there could be life living underneath Europa's thick icy shell. It also has a metallic core, very similar to every planet we have, and a rocky interior. And this slide, I won't go over it in great details, but it shows Europa compared to Earth. So as I mentioned, Europa has 2 times Earth's water volume. That is huge. That alone is one of the main reasons why scientists want to go and do that. And it matters, again, because nearly everywhere that we find water, we find life. And Earth's oceans are home to 50 to 80% of all life on Earth, with at least 224,000 named species. So if we can harbor that here on life, what could Europa be hiding underneath of its icy shell? Earth's oceans are also home to exemplophiles that are organisms that survive everywhere from freezing temperatures below Arctic sea ice to boiling temperatures and high pressure near deep sea hydrothermal vents. So Europa has all of these different elements. While the top is a thick ice crust, something has to happen for beneath to be, not solid, for it to be flowing water, which is really amazing. And so what are ingredients for life? So this goes back to a term that we use called astrobiology, which is showing and looking for evidence of favorable conditions for habitability. This can be in terms of water, chemistry, and energy. So water, again, we keep talking about water, but that's the main exciting part about this mission is what is in the water. So water is at the top of the list for ingredients that make life possible. It can dissolve nutrients for organisms to eat, transport chemicals with living cells, and allows those cells to get rid of waste. Chemistry, for Europa to be potentially habitable, it would need to have the essential chemical ingredients for chemistry of life. So these include carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And usually before this, and a lot of scientific evidence before this, you would think you would need photosynthesis or some type of direct light source for life in order to happen. And they found out along the years that this is just not true. So that having these chemical components in the ocean can give way for habitability elsewhere. And lastly, energy. Life needs an energy source. And so Europa is far away. Sorry, my ear pods keep falling out. I need to talk to Apple about that. The sun is far away from Europa, and a lot of the energy that the moon gets is from the radiation coming from Jupiter. So scientists believe that Europa's surface is created by that radiation from the giant planet, and also may create fuel for life in an ocean below the surface. So the idea that the water's moving and it's flowing like our ocean can be due to the radiation heating up towards the center, and that conduction and convection happening below Earth's surface. So this is an image of Europa Clipper, the spacecraft. I have to admit, I don't think it's the prettiest spacecraft in the world. It looks quite boring, but it is set to do many wonderful things. It has a solar array, a magnetometer boom, and a lot of these things probably seem like jumbled in another language. Oh, and Bruce, I can send you these slides to have that. I'm gonna look at this other screen because it's bigger, but I want you to know that I am paying attention to you. So some of the elements that are on this spacecraft, this slide is one of my favorites because showing you a slide of a spacecraft with a bunch of different callouts doesn't really mean a whole lot, but some of you in engineering, you might find that very interesting. And I do have a slide in the backup slides that show the detailed science instruments, but this is a really great look. So as you can see in the upper right-hand corner is Jupiter. And then at the top, we have the icy crust of Europa. Then we go down to the ocean. So each of these circles represent what part of the spacecraft's science instruments will observe to help define these science goals. So to name a few, it has a mass spectrometer, which we call, it's like sniffing atmospheric compositions, a mouthful, right? So seeing what type of chemistry, what kind of chemicals, what is happening above the surface of Europa that scientists can go look and have further evidence of could life be habitable with these elements. Suda, which is a surface and plume composition. Europa Clipper, it has been proven they have vapor plumes on its surface. So this particular instrument will be able to detect that, see what the vapors are made out of, what chemical composition they are, and also measure them. We also have a plasma detector. We also have an ultraviolet spectrograph. That is also going to be able to detect the temperature, so we can see what varying temperature levels and height and depth of the surface and plumes and its atmospheric conditions. Again, to learn further about what makes up this icy crust and what lies beneath it. We also have a camera that has a narrow and a wide angle camera that's able to help map alien landscape in 3D and in color. This is really important because the images that I showed you in about, I think it was like slide 3, that showed the surface of Europa, these are old photographs taken by the Galileo spacecraft. And while they are beautiful and amazing, there's so much of Europa that scientists have not been able to see clearly and see up close. So this particular science instrument will be able to look deep deeper and map out different regions of Europa, so that hopefully in the near distant future after launch and observation, we'll be able to perhaps land a spacecraft on the surface of Europa. And so at JPL, we have we're going to call it a technology concept called Europa Lander. So we're hoping after Europa Clipper is launched, we get really great data back. The next phase, we'll be able to send a lander that will land on top of Europa. And it looks really cool. It's a robot. It kind of reminds me of a tarantula with how its legs kind of set up. But lander will be able to hopefully land on top of Europa, and then maybe be able to drill down within it and collect more specimen for that. And that is it. If you'd like to know any more information about Europa Clipper, you can visit europa.nasa.gov, or Bruce does have my email address. I can try to field science questions the best that I can. I am not a scientist or an engineer, which you're probably asking me, how did you get this job when you're not a scientist or engineer? I do have a great love and passion for science, but having a skill like communications really is versatile and really needed in the science world. One thing that I want you guys to remember as you're going through your course of study and thinking about as you pick your career trajectory is developing really great communication skills. I know a lot of people don't like speaking in public, but it's really great because we use engineers and scientists to tell the stories of our mission. So while I can give a talk about it, it's even better when one of my colleagues that's a scientist or has created some small technology that's a part of the spacecraft to be able to tell that story as well. So having good communication skills will not only take you further just in your careers, but public outreach folks, we need you to help tell the story of our missions. And that's all I have, unless anybody has any questions.
So we're open to questions right now. Everybody can ask them. You can raise your hand or you can write them on the chat. We already have one. It's from Natalia Vilchis, and she asks, is Europa Lander developing at least conceptually?
Yes. So there is a concept and a design. I will add a slide for that into the slides that I give to Bruce, and so that you guys can see it. So there's already a design artist concept out there, and there's actually a team actively working on this mission.
That's great. We have another one. Have protocols been developed regarding what to do if life is found?
So I think that is the next evolution. So while scientists are very hopeful and that there are life, this mission will be able to help prove that. And once it's proved, I'm speaking in absolutes because I really hope that it doesn't, but in the event that habitability is proved, this can give NASA further evidence to have another mission go in at a later date and explore further.
It's amazing. I'm so excited about it. So Alexander Leon says, how long it takes a mission to arrive to Europa?
So that depends. So right now, the mission is in the process of figuring out what the trajectory will be. And if any of you guys love physics, I do not love physics, but my colleagues that love physics have the coolest job that they get to plan out the mission route. And so it depends on the type of rocket that the spacecraft will be deployed in. So right now, the mission is working to figure out which rocket that the government essentially is going to let us have to deploy this. And that will all be dependent on if we have to do an Earth flyby or we have to do a gravity assist from Mars or from Earth. So it could be anywhere as short as 2 to 5 years to 8 to 10 years, depending on the rocket that it gets launched out of and the trajectory picked it from that rocket. So it's a long waiting game. You would think we could get there in a few days like the International Space Station, but it takes about 8 years. I believe for the Juno mission, which orbits around Jupiter, it took 8 years for it to arrive to Jupiter from Cape Canaveral, Florida.
Wow, that's a long time.
Yeah.
That's a really long time. I have a personal question.
Yes.
So I think engineers, we're not very good at communicating. Like, that's not our strength, definitely. So you told us that we need to improve it, but what would be your advice for us to improve our communication skills? and how would they help us to work either at NASA or at this scientific companies, and how will it help in our careers?
Absolutely. So right now, I'm not sure how your schooling is set up with COVID, but I'm sure there's still a component we're all able to communicate over Zoom or WebEx or any of these awesome different technological platforms. But speak up in class. Don't be shy about, you know, answering questions. When you have presentations, prepare for them. There are a lot of great tools. You can go on YouTube to learn different types of public speaking skills, but honestly, practice, practice, practice. I know even for me, I can speak to anything, but when it comes to presentations, it can be a lot nerve-wracking, especially when you're with a room full of people that you don't know, or even with people that you do know. So practice, you know, write out notes for yourself in case you get lost or you get tripped up. Practice your presentation, right? So that you can hit those marks. And I like to think of it as storytelling. That's one thing communicators are trying to evolve and push that agenda, especially for engineers. I work with engineers and scientists all day. Andrea, I appreciate the fact that you've recognized you guys are not good communicators. You guys are really great one-on-one, but being able to take super high level, dense information and boiling it down to something that we say like a kindergartner can understand is an important skill. It's a hard skill. I even have a hard time doing it, right? Because you think, well, you know, this, everyone should know this, but not everyone does. So just being able to take a look at your work, and you can do that as a practice now, right? You're preparing, you have a paper, you have a presentation due, you know, every once in a while, take that paper, look at it, and then go and like, how could I do this so that my little sister or niece or kindergartner can understand, right? And start practicing doing that, and even doing it on your own presentations. While your professors are super smart, I'm pretty sure sometimes they're like, I don't know what this is, because you guys are super smart as well, right? So just practice speaking in plain language, as I like to say, and take up as many opportunities as you can to get in front of people to practice that. And if you guys have any writing courses or public speaking courses that you can take in as elective, I would highly recommend that.
One for me, if I could, please.
Yes.
I come from the old school, 2001 Space Odyssey, Arthur C. Clarke. When I grew up, when I was in high school, this stuff was science fiction. Now you have a mission. You're sending a spaceship to Europa. You have the budget that was achieved. How does that actually feel to be taking this to the next level, like not going back to the moon again, but you guys are really carrying it forward? What does that feel like in your team when you're working with your people there? What's the buzz? How are people feeling about the mission inside the team?
Yeah, they are so excited. A lot of people have built their careers around the fact that this might one day happen. Each and every one of you, on whether it's an aerospace or space specific mission, or even if you go into the technology sector, there will be that one project that you might have thought up in grad school, or that you're dreaming up in your head, and someone gives you the opportunity to voice that and bring pen to paper from a idea or concept into life. And it is such an amazing thing for me, someone that's fairly new to JPL in this mission, to see that sense of accomplishment, to know that you pass these different milestones. So there's different mission phases. If you guys aren't familiar with mission phases, I'll also put a link to that in the package, and it shows NASA's process for selecting missions. And once a mission is selected, there's different design, we call it critical design reviews. So there's many stages that happen until we get to the point where we're at in Europa Clipper, right? A lot of meetings, a lot of check the boxes, a lot of yes, no, start, stops. But once you get here, I don't want to say it's easy sailing, because there's so many things that can happen in between, but that hard work pays off, and it really motivates the team and brings us into togetherness, to know, like you said, something that seems so sci-fi to happen today. When I was at my previous job at Northrop Grumman, and I was doing the James Webb Space Telescope, and if you guys aren't familiar with it, it is the largest, most technologically advanced space telescope ever built. It is humongous. there was such a great sense of pride for me, especially being on that team, knowing that in the next 3 to 5 years, you know, it won't even take that long to get in orbit. So the launch date changed. So I think it's going to go out in 2 more years. So I guess, yeah, in the next 3 to 4 years, we will know how our universe was formed. We have no idea what the first stars and galaxies look like. And this machine is going to be able to tell us, right? Right after the Big Bang, we're going to know what happened. That's a dream. I've met the people who sat in a room over beers, because scientists love beers, right? And engineers talking about what if we could do this? And it took one person, not one, but people at NASA to be like, you know what? Okay, if you can mark off these goals, maybe. And then that maybe became a yes. And that yes became this most magnificent time machine you'd ever felt. And just seeing it from drawings to the first pieces being put together to actually seeing its final form is amazing and an astonishment. And one thing I hope that you all will be able to do, especially with Europa Clipper, we haven't started, we're in the beginning phases now to move forward with actually building the spacecraft. And so one of my goals in public outreach, because we do have a long way to go, right, until it launches, is that we sit there and I make sure each of you are able to come on that journey with us. So you'll get to see the pictures of the first wrench being turned, and that you'll see once it gets from this step to the next step and from paper to the end spacecraft, that you guys will be able to come along on that journey and ask these great questions and be exposed to it.
Thank you.
Great. We have a question from Drew, and is Europa water fresh or salty?
Salt.
Okay, and Mitzi has another question. How is a geologist are involved in the mission?
So geologists can be involved in the mission, and once we get the data collected about understanding its geology, so like we talk about mapping out different areas on the spacecraft, that information gets used to figure out different aspects of the moon that we haven't seen before, but it also furthers other missions. While this mission won't be retrieving and bringing back any hard materials, just knowing from a data collection standpoint and scientific standpoint will help support the need for Europa lander to be able to come, because we'll be able to say, well, we know at these exact data points we found evidence of X. And so we can go map out and look at X, Y, and Z and test this soil and test this piece of rock.
Thank you. That's amazing. I think this is a multidisciplinary team, and that's great about it. I have another question. Is there a level of precision from the images from now and those which will be taken in future?
The answer is yes. I do not know the specifics, but I will find that out for you and get you the right answer.
Adrian has, I thought Adrian raised his hand. So he was thankful for your answer. So Isaac is asking, thank you for your webinar, but which will be faster, air flight or by gravity assist? How both of them work?
So how do both of them work? So with spacecrafts, it will always be through a rocket. It just depends on the trajectory that it goes by. So Mars gravity assist will absolutely get it there a lot faster. I believe it could get it to Europa in 5 years instead of 8 years. But if we have to go a long way around Earth once, and then another time, and then another planet, then it's going to take twice as long.
Oh. That's long. That's longer. Yeah. A long time already. So how about the proposal of using the International Space Station as docking station? Will it be cheaper and will it be faster?
That I do not have expertise in human spaceflight, but I can take note of that question and I can get a response for you.
Oh, that's great. Thanks so much.
Yeah, you're welcome.
I don't know if anyone else has another question.
Here's a philosophical one, off the record. NASA's been pretty clear in the last 10 years or so. It's not about if there is life on, other planets or beyond Earth. It's a question of finding it, or maybe it was life from a long time ago. Imagining that moment when NASA makes the announcement, whether it's on Mars or on your missions, what's your impression about that, and how will that impact the way we think here on Earth?
It will have huge implications. If you could just imagine just individual, like not even thinking about it being NASA, I think every person of every generation has always wondered what else might be out there, right? It can't just be us, you know, the sky's too big, our solar system is too large, the universe is way too big for it only to be Earth and only to be people like us. Will we find it in our lifetime? I hope so. That'd be great to be the generations that get to experience that. But it will fundamentally change how we do science. If the US is the country to find it, it will fundamentally change the agency and our stamp on space exploration and history. It'll also give way, off the record, of course, it'll give way to really think about how we can go to other planets and how we can go create colonies elsewhere. As you guys know, going to Mars is something that the agency is thinking about. Well, how can we send astronauts to Mars? How can we survey the land? Really great plug. The Perseverance rover is going to be launching next week, which is super exciting. Hopefully you guys can watch the launch, and I can give Bruce also some information on that, and to watch it land. There's so many cool aspects of Perseverance rover, but it's furthering looking what happened back so long ago. Is there more evidence for life that we don't know about? So I just think it will further help with our science, our strategic goals at the agency moving forward, and also just giving humans just another look. Like, there's life bigger than us. We just need to know what it is and where it is.
Thanks.
That's amazing and exciting. I don't know if anyone else has some more questions that you would like to ask. If not, we will go to our book raffle. Yay! And Bruce, I don't know if you wanna talk a little bit about your book. I already promoted it because I loved it so much. I think everyone should read it. But
oh, thanks. It's called Así a las Estrellas, Costa Rica and la NASA, to the stars, Costa Rica and NASA. I'm not sure if I mentioned much about that, Lindsay, in our correspondence, but we're very lucky here in Costa Rica to have several, or at least 4 or 5 Costa Ricans working at JPL. One of them, his father came from Costa Rica, Eric Aguilar. He's one of the lead guys on the mission for the soil retrieval program. And in fact, he was the first person to speak in our JPL Speaks to Costa Rica series, which started, I think, like 2 or 3 months ago, and you're the last speaker in this series. So we're really, really grateful, for you speaking today and capping off this amazing adventure, because each of the speakers and each of the events had something unique and just, tweaks our imagination. The book, it's about technicians, aerospace engineers, robotics engineers. Costa Rica is pretty well represented at NASA. And there are other people that we don't know about, probably. It turns out that there was a lady who works in the human resources department at JPL that we just found out about a month ago. So, but as you know, in JPL, it's a pretty multicultural, diverse place, right? So it was an amazing opportunity for us to write a book and share that with young people. And we do a lot of workshops, and now we're doing it mainly online. So we've kind of shifted to this format. So thanks to people like you, Lindsay, for bringing the inspiration and giving us a little plug with our book. And the Costa Rica Institute of Technology has given us a couple of ebooks that Andrea will help us to raffle off. So have fun.
Okay, Mauricio's there right now.
Yes, we're ready.
Amazing. We're ready?
So
Hit the drums. Oh,
Hey, hey.
No, another one. I already have my book.
That's.
Let's do it again.
All right, that's another one.
I need an autograph though.
Mitzi Cruz.
Yay.
Yes, she's here.
Yes. Mitzi, if you could send us your email.
Yes, please. You can just paste your email on the chat box and we'll
Yes.
contact you.
That would be great. So thanks a lot. Oh, we have more.
We have 2 books,
Oh, great.
and it looks like Diana.
Yay.
All right, thanks everyone. Diana, please put your email in the chat and we'll be contacting you.
Great. Thanks so much, everyone. Lindsay, Alexander, like you're so inspirational, and I mean, it was amazing to have you today. And as Bruce said, it's our last presentation, so it was like a cherry on top of the pie. It was great.
Thank you so much for having me. I enjoyed meeting all of you. I will drop my email address in the chat. So if you guys have any questions or want to reach out, please feel free to do that.
Thank you. Thank you
Thanks
for allowing
so
me to present.
Thanks so
Thanks
much.
so much.
Thanks so much, Alex. You know, great to. I'm from Canada originally too, so feeling really proud to see how Canada can participate and show Costa Ricans good opportunities. Canada's got a pretty cool space program as well, and thanks so much, Lindsay, and great to see you all. Thanks for tuning in today.
Hey, Bruce. Perhaps, sorry to interrupt you, perhaps you don't know, but there's a Canadian at the meeting today. My boss, Tammy Ames, has been at the whole conference. I didn't introduce her because we started right away, but just to let you know that their commercial concert was participating also.
Awesome. Hey, Tammy.
Well, I think we all can go to have some dinner right now. Thanks so much, everyone, for being here. Lindsay, thanks so much. You are so inspiring, and like all this mission is mind-blowing. I'm a biomedical engineer, so you can imagine my biological brain thinking if there's life there. It's crazy.
Please send me an email. I have somebody that I'd like for you to meet, so send me an email.
Sure, I will. Thanks so much.
Awesome. Thank you, everybody.
Okay.
Goodbye,
Thanks, Lindsay.
everybody.
Bye, Alex.
Have a nice
Bye, everyone.
week.
Bye.